Hey students, a very warm welcome to all of you. So all my atoms, I hope you all are feeling absolutely awesome. Your Anubha ma'am is welcoming you to the session, and so many students were telling me that, ma'am, when are you going to upload a one short video of a chapter and CBSE 10th class? Ma'am, hear you. And this is the very first session, that is chemical reactions and equations, one short video. In this video, ma'am is going to tell about all the important topics as well as the entire chapter, so that when you're done with the chapter, you can see this video and have a quick revision and can attempt all the important questions. So happy, excited, a bit nervous that exam is coming soon? Do not worry, why to fear? Your Anubha ma'am is here. Keep following all the videos, and chemistry portion is going to be very easy, and I'll take care of all the things that you'll get everything. So let's start. Please follow this channel equally. Please subscribe to the channel and share it to your friends, and let's make this channel also a very big hit. Yeah, students? So before going ahead, for all the newcomers, all the new students, let me tell you how Vedantu platform can help you to solve all your problems, like if your doubts are not getting solved instantly and you're stuck with something. So at this platform, Vedantu actual platform, you will see your master teacher with the team of teachers called as class teachers. Make sure that all of your doubts can get solved instantly. Notes after every session, so that you will not struggle by writing each and everything, and your 70 to 80% time is wasting like this. Not wasting, definitely it will give you so much knowledge, but then you have time issues. You can utilize this time in revising. So that's also possible. Every 15 days test will be going to happen, so that your revision will be up to date, and you will be like, I am getting all the topics, I'm revising it, so no one can stop us to score 95% and above. That's totally possible. Competitive exams preparation, like side by side, if you want to prepare that, I want to prepare for NTSC, JEE, NEET, Olympiad, totally possible, students. We have these foundation classes as well, and the best part is that is going to be the most benefited is you can choose your own schedule. Now that struggle is over, that I'm having some other work at that time, how will I attend the session at the same time? So you can choose your own schedule, and you can choose the language among Hindi, I must say English, or English. That's what we are doing at this YouTube mode also. That's what we are preferring at our platform also, Vedantu platform. So every problem will be solved here with so much of bonuses that is of your highly interest, that unlimited live classes you can attend here, 8 to 10 if you're free, and you can manage accordingly your chapters and your revision. Micro courses, chapter based courses, if you're stuck with a particular chapter, you can revise it like 8 to 10 times or 100 times, all up to you. Crash courses as well when the syllabus is over. Performance reports in session, leaderboards in every session, so many quizzes, so that you'll get the feeling that you're getting everything and you're making sure of the same. Also, that will be so much fun, and personalized attention of your master teacher as well as a group of class teachers totally dedicated to help you all. Yeah, students? And I make sure in that sense that how Vedantu is a best online platform, because if I talk about JEE Advanced exam, that's the toughest exam of India. There are so many students of Vedantu who back top ranks. How? Just see that. Top 500, 5 ranks, top 1000, 11 ranks, top 2000, 44 students were there in top 2000, top 5,121 students, top 10,000, there are 253 students. So definitely, students, if Vedantu is there, this is possible. And yes, I am saying that I'm a proud Vedan. You will feel the same, and you will make sure that you will get everything and you will feel motivated. These are those amazing students, and your picture can also be here. I totally believe in you. Yeah, students, totally believe in you. So students, for all the updates of the pro classes, of the pro courses of Vedantu, you all have to do one thing. Visit the link given in the description box, and then apply a magical code, that's AGEPRO. Anubha Gaur ma'am, AG ma'am, E English for this channel, pro is the course. So AGEPRO course is must. When you open the link, this page will be there. You have to select your grade 10th, select your target CBSE 2021, and then click on get subscription, and you can choose among 1 month, 3 months and 6 month subscription. Now ma'am, which one is best if I really look for the same? For 1 month, it just, if you apply AGEPRO code, you will be able to save 20%. For 3 months, 31%, and for 6 months, 43%. So it's all about monetary benefit that you're going to get. The courses are exactly same. You'll get the maximum benefit of all of it. It's just the duration. I must say 1 month will be very less. 3 months is like a moderate one, and it's like December, January, Feb, and you make sure that your revision will be completed. So you can choose accordingly and get the maximum benefit by applying the coupon code, that's AGEPRO. Yeah, students, you got everything? Give me a quick thumbs up. Yeah, and we will start with our topic, chemical reactions and equations. I will revise it completely, so do not worry. I am here to help you out. Stay motivated, stay happy, stay calm, and be with me till the end. Okay, students, so let's start. Let's start right away. We will not make any further ado. Now the cases, I'll ask some day-to-day life examples that you have seen around you. You might have, put proper attention over it, and sometimes you're like, no, I don't care. But try to be that curious student and try to see things around you. I'm talking about science. When you keep your milk open for some of the time, you see that starts curdling up. That is something that's giving you maybe paneer, maybe cheese, and maybe curd. So what exactly is the reason behind it? Do you remember that? Do let me know in the comment section. What about the iron nails? Even there are so many iron objects in your home. After a few months, that will turn like this reddish brown. They will be rusted. What exactly is the reason for the same in humid environment? Something, now you're getting it, that they are creating some chemical changes. Chemical changes means they react with some of the things and giving you new substances. So students, your day-to-day life is filled with so many day-to-day life examples of chemical changes. If I talk about your iron nail that turn reddish brown because it reacts with the humidity, air and moisture to give hydrated iron oxide, that's your rust. When I talk about your milk, milk is having a bacteria, lactobacillus, and after, in that hot environment, that will be giving what? Converting to lactic acid in the milk. Milk is having lactose sugar that convert to lactic acid, and that's how you got your curd. So chemical reactions, chemical changes, new substances are forming. And students, there must be a proper way to write each and every chemical reaction. Are you agree with me? There must be a proper way. Every time we can't say this, and making big sentences. So in this chapter, we'll talk about how to define a chemical reaction, how to write it, and so many other types of the same. So students, if I talk about laboratory, that you're going to laboratory and you're like, let me see if I can perform a chemical reaction, yes or no. Definitely, the very simple example that's there in your textbook is this. If you're taking a magnesium ribbon and you start burning it in air, what will happen? Your magnesium react with the atmospheric oxygen. We have provided enough heat also, giving you a new substance, that's magnesium oxide. How we are making sure that we got magnesium oxide? A very bright white dazzling light is going to produce, and a powder starts coming out of the same. That white powder is nothing but magnesium oxide. You got a new substance. That's what a chemical reactions we perform in laboratory too. Yeah, students? Got it? So what I meant by this, that how a chemical reaction happens in day-to-day life or in laboratory, you are going to take 2 or more substances. They are going to react with each other. Whatever substance are reacting is called as reactants. They react with each other and give you some new substance with entirely new property. And that substance is called as product. Okay, that substance is called as product or products, if more than one. That's what a chemical reaction is. Okay, I hope it's pretty simple and you got it. A process in which one or more substances are going to react with each other to produce one or more new substances. yeah, with entirely different property. And how you can make sure that when you go to laboratory, you're like, yes, something has happened, a chemical reaction has happened. You can make sure by knowing some of the observable changes you'll see in the reaction, and you're like, yeah, I got it, yes, completely, I'm with you. So the very first example in change in state, that how a different substances with different physical state is going to combine to give a new substance with entirely new physical state. The very common example and very famous one is in there there in front of you. I took ammonia gas, I took hydrogen chloride gas. You won't call it hydrochloric acid, because if that will be acid, you must have written AQ, aqueous. Acid shows acidic property in aqueous solution, in water. Otherwise, it's just a gas. So these two gases are going to react with each other, kind of combination. They are going to combine to give a single substance, that is ammonium chloride, white color, powder type of a substance in solid form. So I observe by reacting two gases, what did I got? I get my ammonium chloride in solid form. Change in states, best example. Now you see ma'am is writing every reaction with what? Writing something in the bracket. And what is this, students? The physical state. This is making your reaction more and more informative. So you should prefer it. Okay. Second one is change in color, that if I'm doing some of the chemical reaction, if I got a new substance with a new color, that is definitely, you can say, is a reaction where change in color is happening. Very famous example that you're knowing from your 8th class also, if I'm not wrong. That how if I put an iron nail into copper sulfate aqueous solution, which is of blue color, this is like a grayish white color, I see a color change. I got iron sulfate in the same solution, like of this color, pale green color is going to come, and that copper that was free starts accumulating on that iron nail, that's reddish brown. So see that, what did we get out of the same? See the color changes. Isn't it amazing? So yes, students, change in color is also an example to see whether the reaction has taken place and the characteristics of chemical reaction. One more, that's evolution of gas, that how come when two or more substances are reacting, we are getting a product that's in the gas form, and gas is leaving your test tube or beaker. Okay, and always remember, whenever metal react with acid, you'll always get metal salt and hydrogen gas. Metal salt and hydrogen gas. So I took zinc metal and I put it into sulfuric acid, and this is a very good example, as you know the chapter already. Zinc being more reactive is kind of displacing hydrogen and telling to hydrogen, hydrogen, you go away, be a loner. Okay, so you got zinc sulfate, a metal salt, and along with that hydrogen gas. What are you getting? Hydrogen gas. And how you can check hydrogen gas? If you put a funnel over it, if you put a glass tube over it, and two things you can do. If you pass it through soap solution, if you pass it, this gas through soap solution, soap bubbles are going to trap hydrogen gas, and whenever you are going to take a burning candle near it or burning matchstick near it, it will burn with a pop sound. As simple as that. So you can also detect your hydrogen gas. Not necessarily hydrogen gas. I can show this reaction also, that if I heat calcium carbonate, what I'm going to get? Calcium oxide along with CO2 gas. CO2 gas. And how you can check that? That the gas is CO2 because that's turning your lime water milky. Yeah, one example in front of you. You can tell me other way to detect CO2 gas in the comment section. That is very easy. 8th class thing. Okay, even change in temperature is also one of the example, that when you're performing the reaction, if the beaker after some time became hot, or if the beaker or flask, whatever you have taken, became cold, that's also telling a change in temperature, and definitely that a chemical reaction has taken place. So there's one example in front of you, that how ammonia is reacting with sulfuric acid. Again, what did you see here? That's, I'm taking a concentrated sulfuric acid, and that is doing what? The product is like I'm getting a kind of a salt, a kind of compound along with H2O, water. So ammonia with sulfuric acid, I got ammonium sulfate. It's like H2 hydrogen and then sulfate. So ammonia will give you ammonium sulfate. I'll take 2 molecules of the same. 2NH4, it became 2NH4, right? And then SO4. So I got ammonium sulfate along with H2O in this. And what did we see in this reaction in front of you? That when I touch it, it is a bit hot, exothermic, that's release in energy. What is exactly meaning of exothermic, students? Reaction is of basically two types. If I talk about change in temperature, one is exothermic and one is endothermic. All right, one is exothermic and one is endothermic. Exo means outside. Yeah, exo means outside, and when I talk about endo, endo means inside. Okay, exo means outside and endo means inside. Thermic means definitely heat. Thermal, related to heat. So change in temperature reactions will be of two types. Outside heat, if the reaction is releasing heat and the beaker will become hot. Endothermic, inside heat, if the reaction needed some amount of heat to perform, they absorb the heat and the beaker will be a bit cold. And I can definitely give you more example for better understanding, students, because that's what I want from you, right? So exothermic, one more example. All the combustion reactions are exothermic. Burning a substance, magnesium burn in air, that's an exothermic. Coal burning in air, your LPG burning in air, exothermic. Endo means inside heat and day-to-day life example. Photosynthesis, that how your plants absorb sunlight to perform a chemical reaction. Okay, very simple one. I hope you got it. There's one more that you can see, that's formation of precipitate. That how come when two or more aqueous solutions are going to react in laboratory, you see whenever these two aqueous solutions are reacting, one of the product is in the solid form and settle down at the bottom of test tube. Very simple. So it's like having two aqueous solution, and what they'll do, they're like, we are bored of each other's company, let's just exchange position. So barium is like, I'm going with sulfate. Sodium is like, I'm going with chlorine. Do let me know in the comment section what this type of reaction is. Your comments are highly appreciated and making me figure out that you're learning everything. So sodium chloride, 2 molecules, and then barium sulfate. And what will I observe? White precipitate, white solid powder settling down at the bottom of test tube whenever you mix it. So that's what is precipitate, a solid insoluble product that I'm going to get. Look at this, something like this. So I hope it makes sense. I hope revision is going absolutely fine and awesome. Yeah, so now it's just chemical reaction should be written in a better way rather than writing big word. Magnesium plus oxygen gives magnesium oxide. So what we'll do, that we'll write every chemical reaction in a better way, in a simple way. And what that simple way is, writing a chemical reaction in terms of using symbols and formula. So rather than writing magnesium and oxygen giving us magnesium oxide, that's what my product is. Rather than writing in this side, we'll write it in a better way, that I'll use the symbol and formula, that I will write what? I will write magnesium reacting with oxygen to give magnesium oxide. I know that you know this much now. Yeah, using symbols and formulas of the elements and compounds that is there in the reaction. Okay, so chemical equations I can write in two ways. One is called a skeletal equation. What is chemical equation? Writing a chemical reaction in symbol and formula, symbolic representation. Skeletal equation is what? When I'm just using what, students? When I'm just using symbols and formulas. So in this reaction, what did we see? I took my potassium nitrate, and when I heat it, it is kind of decomposing to give me, potassium nitrate is decomposing to give me potassium nitrite. This is nitrate. This is potassium nitrate decomposing to give us potassium nitrite. More oxygen, 8, lesser oxygen, 8. With oxygen released. Now this is just a skeletal equation. Means I'm not very much sure that the number of atoms are equal on both the sides. And there is one more way, that's a better way, that's balanced chemical equation. Writing the chemical equation in what way? A balanced way. Balanced way means I'll make sure that I will see the number of atoms equal on the reactant and product side. So when I take 2 potassium nitrate and wrote 2 potassium nitrite with oxygen, the number of potassium, the number of oxygen, the number of nitrogen, everything is same. 2 nitrogen, 4 and 2, 6 oxygen. So this is a better way to write a chemical equation, and that is writing a chemical equation in balanced form. Okay, why we have to balance a chemical equation? Just to justify law of conservation of mass, which simply said, what is law of conservation of mass? That whenever I started the reaction, whatever is the mass of reactant, and when the reaction is completed, the product, the mass of product must be equal when I'm doing the reaction definitely in a closed system. Otherwise you will say, ma'am, what we'll be getting some gases and gases will be evolving out. No, that's not you have to approach. In a closed system, mass can neither be created nor be destroyed. I can't say some of the mass is destroyed, some of the mass came up on its own. It must be same, and to make mass same on both the sides, we have to make atoms equal on both the sides, because atoms are responsible for the masses, and you know that, right? So the main way to balance a chemical reaction is to follow the law of conservation of mass, and the one that's there in your syllabus, the method, that's hit and trial method. We're hitting some number and we're trying it, we are using it. So what are the steps that we are going to follow? Follow these steps if the question will come in 3 marks. You are not like, okay, I will not make any of the proper way and I'll just make a very chaotic representation and that's it. No, that's not the right way. Write all the possible steps if the question is for 3 marks. 1 mark, you can simply tell in very short. First of all, write a balanced chemical equation, that how come my hydrogen is reacting with chlorine to give HCl. How my hydrogen react with chlorine to give HCl. Okay, students. So this is just an unbalanced chemical equation. Second, we'll count number of atoms on both the sides. Counting number of atoms on both the sides is very simple, that I just make sure that I have 2 hydrogen and 2 chlorine on the reactant side and 1 hydrogen and 1 chlorine on the product side. Numbers are not equal, I'm done. And how did we do that? Multiply coefficient with subscript, that's what we did. Multiply this coefficient, the coefficient that we write in very starting with my subscript, then I can make the number of atoms equal. That how would I know how to make atoms equal on both the sides? So that is what I'm telling you right away, that you will write some coefficient in very starting. Coefficient is nothing but a whole number, in such a way that when you multiply them with the subscript that we are writing here, with the subscript, the number of atoms will become equal on both the sides. Coefficient into subscript will give you the total number of atoms. And if your reaction is, suppose you wrote it in this way, 2 hydrogen, 2 chlorine, I got 4 HCl. Now look for this point, if necessary, reduce coefficient to lower possible ratio. That I'll write it in simplest possible whole ratio. So I'll divide it by 2. I got H2, Cl2, 2HCl. Did you get the point? We'll write it in the simplest possible number. Okay? Update and double check that the atom and the reaction is balanced. That's what we do. Okay? And how you'll make sure that, yeah ma'am, we are understanding it, if you will do enough kind of examples, because doing examples are very much important. So at least you should practice 15-20 examples, whatever is given, at least in NCERT. Suppose I have to balance this. This is very much easy. Coefficient is nothing but 1. If nothing is written, means 1. That's giving 2 hydrogen, 2 oxygen, 2 hydrogen, but 1 oxygen. Number of atoms are not equal on both the sides. How will I make it equal? By writing some coefficient in the starting, which makes the number of atoms equal. Now this became 4 and this became 2. So oxygen here is 2, 2, but hydrogen here is 2. So how to make it 4? To make number of atoms equal, I can also multiply this H2 with 2. As simple as that. By writing simplest possible whole number. Yeah? So is it clear? Not at all difficult. I know that you got it. It's not at all difficult. So let's have one more example. How come C6H6, whenever going to react with oxygen, produce CO2, H2O, and definitely energy? This is nothing but your benzene. I am burning benzene in air. That's giving, do remember, whenever you have any hydrocarbon and whenever you try to burn a hydrocarbon, that will always give CO2 and water vapor. Let's see how to balance it. Number of carbon 6, number of carbon 1. I'll write it 6 here. Students, how to approach it? There is one thing that you should remember. Whatever the atoms include, carbon, hydrogen, oxygen, first go for that atom in balancing which is repeating the minimum number of time, which I can see in the reaction minimum number of time. The minimum number is basically 2. There will be some, especially oxygen, that is written 3 times, 4 times and all. So we will do such atoms balancing in the last. Yeah. So I'll approach carbon as it's repeating 2 times, hydrogen also 2 times, oxygen 3 times. So I will balance carbon and hydrogen before. But ma'am, among carbon and hydrogen, which one will I choose? So choose one that's heavy. That's one that's having more mass. So first preference carbon, second preference hydrogen, third preference oxygen. Okay. So 6 carbon, all okay. 6 hydrogen, I will make 6 hydrogen by writing 3. Hydrogen is also balanced. Let's see the number of oxygen. 6 into 2, 12 plus 3, that's 15. How to write 15 oxygen? It's not 2 multiple. You can write it either in this way. 15 by 2. 2 cancel. 15 by 2, O2. 15 by 2, O2. And that if you'll do half of 15, that means you will get the same number. That's what we wanted, that's 15. Or there's one more way. Either I'll do this, the reaction became balanced, the number of carbon, the number of hydrogen and number of oxygen is balanced. Let me erase this and tell you one more way to write it in a better way, because the thing is, using a fractional number doesn't look nice. What will I do? To cancel this 2, I can multiply the whole equation by 2. So it's 2C6H6 plus 15O2 gives me 12 CO2 and 2 into 3, 6 H2O. Now we are done. 12 carbon, 12 carbon. 10 hydrogen, no, that was 6, a mistake. 12 hydrogen, 12 hydrogen. Oxygen is like 30, 12 into 2, 24 plus 6, 30. Now it's correct way. So please remember, you can do that also. It will give you 15O, but the right way will be writing it into a whole number. Okay. So this is the way you can balance. I know ma'am had made so many videos on Umang 2.0 series. Please see the entire series. If you'll be having any confusion, we discuss so many examples over there as well. And you can practice and let me know your problems. Okay, now let's discuss different types of chemical reaction. It's like there will be million of chemical reactions and studying them one by one will be very difficult. So they have classified the chemical reaction on some of the common types. And according to it, there will be 5 types of chemical reaction that we are going to study. Okay, in which my reactants are somewhat having some atoms, they are rearranging themselves to get new product. That's what happens in a chemical reaction. It's just a rearrangement of atoms to get new substances. So the very first one that we need to discuss is combination reaction, something that's getting combined, and very simple, a reaction in which a single product is formed when 2 or more reactants are going to combine. Okay, so that's combination. You can totally download this file. You can have this PDF for quick revision that will be uploaded very soon on the description box. Okay, so ma'am is showing you with the help of amazing GIFs also that how come 2 or more things are coming, reacting to give a single substance. That's what combination, also called as synthesis reaction. So never get confused that these two are different. Synthesis and combination is same only. Very famous example in front of you, that how hydrogen came, chlorine came. You know hydrogen, tiny HH, tiny atoms, chlorine, Cl2, Cl2, big atoms. They are just combining and see what is happening. HCl, HCl, you are getting 2 molecules of HCl. What exactly is this? Synthesis, combination. Two or more things are combining to get a single substance, right? If I talk about decomposition, name is giving you the answer. That's opposite of your combination. And what did we see here? Decomposition means breaking down a single substance to give more than one substance. That's it. Breaking down of a single substance, single heavy compound into simpler kind of a compound, simple type of substances. Yeah. So decomposition is also very simple. Breaking down of a single substance to give more than one substance. Yeah. One example in front of you that they are showing here. We have taken KClO3, potassium chlorate, that was decomposed to give KCl, potassium chloride and oxygen. Anyway, you have to balance it. 2 KCl, 6 oxygen. Yeah, I balance it also. So that was the example that how we get KCl and oxygen in this by a single substance, potassium chlorate. Now that's of 3 types, students. Your decomposition is of 3 types. And what exactly this? That when a single substance breaks down with the help of heat given to it. A substance will not break down on its own, right? You have to heat it. I mean, you have to give it energy, either in form of heat, either in form of light, it will absorb light, or in form of passing electricity. These all are different forms of energy only. So there is one thing that's there in front of you, that we have taken lead nitrate as a single substance. We heat it. For heating, we can use this triangle symbol called as delta symbol also. Do remember, whenever metal salts are going to be heated, that will break down in such a way that your metal, as it's heating in air, will give you metal oxide. Look at this, very famous and very good. You got lead oxide and the rest over substance is going you some gases that is going to come out. So do see that that's a white color substance decomposed to give lead oxide, that's yellow color. A reddish brown fumes, that's of NO2 gas, also oxygen released. And what this is, you can see that here also is thermal decomposition reaction. Why I call it thermal decomposition? Because decomposition due to heat. So that is thermal decomposition. Now the second type is electrolysis, means lysis means breakdown, electro means electricity. Electricity, lysis means breakdown. Okay, when a substance is going to break down, when electricity is passed through it. Very famous example that you know is electrolysis of water. When I'm going to take water, not normal distilled water, I will put some 2 to 3 drops of acid into it. So I'll call it acidified water, because acid is somehow helping water to dissociate into ions so that they can move towards respective electrode. So positive terminal and negative terminal of the battery, and negative terminal of battery is called as cathode because they attract cation, and positive terminal is called as anode as they attract anion. Why? Opposite attracts. So on one of the electrode you will get hydrogen, and one of the electrode you will get oxygen. Where, students? H is in the form of H positive, that will go to the negative terminal. So on cathode you will get hydrogen gas. Oxygen is negatively charged, so you know that every time 2 hydrogen ion will move and 1 oxygen ion will move towards the positive terminal and give you oxygen gas. The conclusion is, when you take 2 molecules of water, you get 2 molecules of hydrogen but 1 molecule of oxygen. The amount of gases produced here is in the ratio of 2:1. Clear? Yeah, students? Electrolysis, breaking down a substance in presence of electricity. And I would love to see some more example of electrolysis in the comment section. Give me reply. All right. Now decomposition in presence of sunlight, that is nothing but photo decomposition or photolytic decomposition, right? Breaking down in presence of light. And now my silver compounds, some of the silver compounds are light sensitive, like AgCl and AgBr, silver halides, silver chloride, silver bromide. Halides mean this. Halide is 17th group of the periodic table, halogens. Okay, so whenever you put them into sunlight, you can use this symbol also, H nu. This is nu. Nu means frequency of light. Light comes with the proper frequency. And Einstein told us that whenever energy comes in a packet, and every packet of energy is defined by H nu. So that's what another representation, though they won't give you. It's like, ma'am, out of the box. Okay, so you will get what product? It will decompose to give silver, and here chlorine and here bromine. It's like your white silver, pale yellow silver bromide decomposes to have a grayish substance left on your watch glass or your china dish, and the gases will evolve out. What example is this? Photolytic decomposition, breaking down in presence of light. Okay, so these are the things that your substance are breaking down in presence of either heat, light, electricity. That means they are needing energy. They are absorbing energy in form of heat, light and electricity, and all your decomposition reactions are endothermic reaction. What is endothermic reaction? Absorbing the heat. That's what all the decomposition reactions are doing. So now you have plenty of examples. Okay, you have plenty of examples of endothermic. And one more thing, exothermic, you can say combination. Combination reactions are exothermic. Okay, like in general. Let's talk about displacement reaction now. This is the third type of reaction. What exactly is a displacement reaction? When a single substance being highly reactive is going to displace a substance, an element, from its aqueous solution or its molten salt. What exactly this what ma'am said? I'll repeat it again. Here the examples are there in your textbook in form of metal. So when you have a reactive metal, when you have a highly reactive metal, that can displace a less reactive metal from its aqueous solution or from its molten salt. Reason to take in aqueous and molten, so that ions will be dissociated, ions will be free, reaction is easy to perform. So zinc is like, I am displacing copper, copper, be a loner, and you got zinc sulfate. Metal salt, and again one metal in the free form. Yeah, you got it? I'll show you. See that example in front of you. Magnesium I have combined with what? Silver nitrate, NO3. Okay, and magnesium AgNO3. Yeah, and magnesium is like, I am more reactive than you, silver. Go, I will take this position. You got magnesium nitrate and bechara silver. Loner silver is free. Okay, so this is your single displacement. I hope it makes sense. I hope you will remember the reactivity series, because somehow this will help you to remember all the elements in an order, that which one is more reactive and which one is less reactive. In the entire reactivity series, reactivity decreases down the group. That means a highly reactive metal can displace a less from its salt solution. One more example in front of you, my iron being grayish white, my copper sulfate, copper, and this is copper sulfate, this is copper basically, this is sulfate, SO4. Okay, iron is displacing copper and we are getting iron sulfate and copper. Now there's one more type of a reaction. Yeah, it is going to be a long one, so stay tight, because ma'am is helping you to revise the entire chapter, that too properly. So students, now the example is our DD reaction. What's DD reaction? Our DD reaction is nothing but double displacement reaction, 2 times displacement reaction. And how that happens? When you have 2 aqueous solution and they are exchanging their ions, that's what a DD reaction is. 2 aqueous solutions exchanging their ions. They're like, we are done, let's exchange. 1 sodium, 1 positive, 2 sodium, 2 positive, sulfate -2 charge, barium +2, 2 chlorine -2. Exchange of ions. Sodium is like, I'm going with chlorine, I am done. Barium is like, okay, I'm going with sulfate. So barium sulfate and sodium chloride. One of the substance in double displacement, when the substances are not acid and base, one of the substance in that case would be precipitate, a solid insoluble product. So what you'll get, you know that 2 aqueous solution exchanging their ions, giving 2 new solutions. If the 2 reactants are not acid and base, one of the product we assume is precipitate. One more example, silver nitrate with KCl, exchanging the ions. Silver is like, I'm going with chlorine. Potassium is like, I'm going with nitrate. I am getting white precipitate of silver chloride here, and the other one will be the aqueous solution. So that's very easy, and some of the students is like, how to remember that? Practice, students, practice will make you perfect. That's what ma'am is trying to help you over there. Yeah. So one of the form of DD reaction is your precipitation reaction, where you get one of the product as precipitate. Lead nitrate with Ki, potassium iodide, aqueous ions, in aqueous solution they'll exchange their ions. Lead iodide, potassium nitrate. Do remember about the valency part also. Do not write the formula incorrect, otherwise the whole equation will be balanced in the wrong way. So that's not the right way. Okay? I hope that's fine. So precipitation is done, Dhanadhan. Let's see, I got a lead iodide yellow color precipitate. Very awesome and very good to see that. Yes, students? And the second type is of your DD reaction is nothing but neutralization reaction. What is neutralization reaction? Reacting an acid and base to give salt and water. Very famous example given in front of you too. That's reaction of hydrochloric acid and your sodium hydroxide. This is your acid, this is your base, and as you know, acids and bases are also having ions, and they'll also exchange ones. So H is like I'm going with OH, N is like I'm going with Cl. I got NaCl along with HOH, that's your water. I got salt, I got water. How did we get that? Exchange of ions. DD reaction is of two types. One that is a precipitation reaction. The other one is your neutralization reaction. Okay, got it, students? Check. Okay, let's talk about this again, which is going to be very, very important. That's redox reaction. The fifth one, redox is a combination of two words. That's red plus ox. Red came from reduction, ox came from oxidation. So redox reaction are a set of reactions, or I'll say a reaction in which oxidation and reduction takes place simultaneously. Okay, a reaction, it's like oxidation and reduction are telling to each other we will live together always. So that happens simultaneously. But let's understand first of all what is oxidation and reduction so that you will understand redox. That we'll explain with the help of a very famous activity given in your NCERT also. That I took copper reddish brown substance and I'm heating it in air. So what will happen in this example, students? My copper, as we are heating it in air, is giving us copper oxide, and my brown color, my reddish brown color copper turned black. So what exactly we observe in this reaction? My copper is taking oxygen and making copper oxide. So can you explain this, why this has happened? Ma'am, I can explain it totally, yeah. Why exactly this happened? Because oxygen is added, and if oxygen is added to a substance, that is called as oxidation in very simple word. Okay, copper with oxygen giving you copper oxide. Really sorry for the same. There is like after downloading the file, some of the arrows are going here and there, but what we concern is our concept must be clear, and ma'am is doing the same. So do remember, students, earlier oxidation reduction concept came to us in terms of oxygen only. Oxidation is addition of oxygen, and reduction is something that's removing, that's removal of oxygen. Okay, so let's understand that with the help of this example. When we take copper with hydrogen and we are heating it, copper oxide with hydrogen, we are heating it. I got copper with water. So look at this example. If hydrogen gas is passed over the heated copper oxide, the black coating on the surface, this is of black color. So the black coating turned brown as the reverse reaction takes place. As hydrogen gas is passed, it will again turn to copper, and the black layer is again gone of copper oxide. I got my reddish brown copper back. I got my reddish brown copper back. So what we observe, that this is removal of oxygen. So this is called as reduction. Earlier definition was limited to this. Earlier definition was limited to only this, that oxidation is addition to oxygen to any element. But hydrogen is like, no, I'm not very happy with the same. So what in terms of hydrogen? Removal of hydrogen from a substance is also oxidation. Opposite job that it is doing in oxidation. removal of hydrogen, and that's something more important. I'll tell with an analogy also. Losing electron to gain higher oxidation state. Like a simple example, suppose you have sodium. You know, configuration of sodium is 281. For getting stability, sodium is losing an electron, right, and becoming positive. So a substance when lose its electron and get positive charge, that's also oxidation. You can remember in the term Leo, ma'am is Leo too. Loss of electron is oxidation. Leo, that's Leo. Loss of electron is oxidation. Okay. In the same case, we have understand different kind of example that adding oxygen, I got copper oxide. That's one of the example of oxidation. We see here as well that if we took copper oxide, let me change the color. If we took copper oxide and pass hydrogen gas back, what did I get? My copper oxide removed its oxygen. So this is what? Reduction. On the other hand, one more thing we saw, hydrogen here took oxygen, right? What do you need to see? From reactant to product, what exactly is happening to the substance? Gain of oxygen, that's oxidation, right? Gain of oxygen, that's oxidation. Removal of hydrogen, that's also oxidation. So please remember that. Okay? Losing electron, ma'am already explained to you. With one more example I'm telling. Look at this. My magnesium is like having 282. This is the configuration. Every chlorine is like Im287. So my magnesium having 2 extra electron, in what sense? If it loses these 2 electron, it will be stable. So magnesium is telling to 2 chlorine, you need electron, I have it, don't worry at all. Magnesium giving 1 electron here, 1 electron here, I'm very happy. What happened to magnesium? Loss of 2 electron, got +2 charge. Here magnesium got oxidized. Look at the chlorine, opposite job. So you remember it in this way. Leo goes to Gr. Leo goes to Gr. So gain of electron is reduction. Look at both the chlorine. They accepted 1 electron from magnesium. And total 2 chlorine accepted 2 electrons, so -2 charge. So magnesium here is getting oxidized. Chlorine here is getting reduced. Magnesium oxidized, chlorine reduced. As simple as that. So I hope now oxidation and reduction is also very much clear, that how come reduction is addition of hydrogen, opposite, and then removal of oxygen, and then gain of electron. Yes, we can understand this also with the help of different example. My nitrogen here became NH3 by addition of hydrogen, and addition of hydrogen is nothing but reduction. That's pretty much clear. Removal of oxygen. Example in front of you, I had iron oxide and I pass coke out of the same. Coke is what? Coke powder is pure form of carbon itself. And what did we see, students? I'm not balancing it. Carbon here is helping iron oxide to lose its oxygen, and iron oxide converted to iron. And loss of oxygen is nothing but reduction. Gain of hydrogen is also reduction. And now gain of electron, I told you any substance taking electron. Suppose here is F2, 2 fluorine. Every fluorine 2 7. 2 electron we have given, 1 here and 1 here. Both of the chlorine accepted 1 electron. So what did we get? Every chlorine is having a negative charge. Gain of electron is reduction. Every chlorine, 2 fluorine, this fluorine became negative. This fluorine also became negative by accepting 1 electron. I hope you got it, that how gain of electron is also reduction. Now redox must be properly cleared in your mind, that redox reaction is nothing but combination of oxidation and reduction. A reaction where a substance is getting oxidized and the other is getting reduced. That's what your redox reaction. So some example in front of you. Look at this. My iron with oxygen is giving iron oxide, and this is oxidation. My iron is getting oxidized because it's adding oxygen into it. My oxygen is getting reduced. In what sense, students? My oxygen, I can explain that in terms of electron because that's a better method. How come? any substance in elemental form is having zero charge. I hope there is no denying in the same. Iron zero charge, oxygen zero charge. When I take any element, sodium, lithium, any of the element of periodic table, every atom is having zero charge because number of proton and electron is same. Positive and negative is same. So my oxygen here is in the elemental form, not carrying any charge, but here it makes a compound, and compound is made when your metal losing electron and non-metal accepting it. So if you remember, every ion is having a valency. I can check the valency: iron 3, oxygen 2. Every ion is having a valency of +3. Every oxygen is having a valency of -2. So in a say, what did we observe, students? My oxygen from 0 became -2. And how come minus charge by gain of electron? My oxygen was 0. Now it became -2 by acceptance of 2 electron. Every electron -1, -1. Gain of electron, what exactly is this? Reduction. So students, sometime you might get confused in the oxidation and reduction in terms of oxygen and hydrogen, but this concept is a better one. That's the gain and loss of my electron. Simple example in front of you: iron oxide to iron, loss of oxygen, reduction; carbon monoxide to carbon dioxide, gain of oxygen, that's oxidation. So one reaction where oxidation and reduction is taking place simultaneously. There is one important note. I hope you missed that, but do remember that all of the reactions are not redox, because sometimes we think every substance is somehow related to this, that redox reaction, and that's true also. Most of the reaction that we understood in combination, decomposition also, single displacement also, is kind of redox also, but neutralization reactions are not redox reaction. DD reactions are in general, DD reaction I should say, are in general not redox at all, because they are just exchanging their ions. Their charge remains same. It's just exchange of ions. No loss of electron, no gain of electron. So they are the ones that's not redox. Look at this. H positive, Cl negative, Na positive, OH negative. Exchange of ions, I got NaCl, again Na positive, Cl negative. What is water? H positive, OH negative. Every ions are just same. It just position are exchanged. I hope you got it. So this is your neutralization, which is not at all a redox reaction. Okay, before moving ahead, one thing is a myth. Let me tell you here itself. That is also an important question, can be asked in exam. What is my Ra and what is my OA? What is my reducing agent and what is my oxidizing agent? So I'll tell you right away. Reducing agent is an agent that does reduction. Okay, and how it can perform reduction of the other substance? By oxidizing itself. This is a very important thing I'm telling you. Question can definitely come. Oxidizing agent that does oxidation of other substance. How? By reducing itself. It's like you do not need to think much, but do one thing. Just see what a substance is doing to itself and the reverse action it will show. It's like my iron oxide is giving you iron, that's loss of oxygen, it's reduction. So if a substance is getting reduced, because it's helping the other to get oxidized, it's helping the other to give oxygen. So this is my oxidizing agent. Look at the reactant site, what they are doing, what job they are doing. My carbon monoxide is getting oxidized to CO2. They are taking oxygen, they are getting oxidized by reducing the other substance, by taking its oxygen. Are you getting it? So this is acting as my Ra. This is acting as my Ra, my reducing agent, because that's what it is doing to iron oxide, reducing it by taking its oxygen. This is my OA. This is oxidizing CO by giving its oxygen. So reverse job they'll do, please do remember. Okay, so that's also clear. 90% of your chemical reactions and equations is complete. Now the main part is this oxidation will not leave us. Very important we see in our day-to-day life. That's not in a good way. Okay, that's corrosion and rancidity, two problems that we face due to this oxidation. So students, this process is corrosion, and something that you know from 8th class, I'm pretty sure about the same. What exactly is corrosion? Is just eating up of your metal. Your metal is getting degraded basically with this oxygen that it is taking from atmosphere. Yeah, there are other gases also that's equally responsible, but oxygen here is the main villain, not every time a villain though. So what exactly is corrosion? Kind of a natural process that how your metal is getting degraded mostly when it reacts with atmospheric gases, water vapor, also with diluted acids. Okay, and the very famous one, you know that, let me tell you, the one that's very famous is iron's corrosion. Yeah, that my iron is getting oxidized. Let me tell you the reaction. My iron is getting oxidized with some water molecule, X molecule of water. I got iron oxide with some X molecule of water, and I will call it hydrated iron oxide. That's nothing but a fancy name, but your rust. Yeah. So rusting is definitely eating up your iron metal with this moisture and harming so much to our economy. Every year, so many iron objects has to be replaced, so many bridges and all, because yeah, that's not a good thing, right? Same, look at our Statue of Liberty that was supposed to be, now that looks also nice, but yeah, that's not a good thing. Your copper that was reddish brown turned to this green color because copper is taking atmospheric oxygen along with water vapor. It's like moisture along with CO2 gas, and making a combination, making a mixture of two products, that's copper hydroxide and copper carbonate. Copper hydroxide and copper carbonate, and simple word, we can also call it basic copper carbonate. OH will behave as a hydroxyl ion release, means it's a base. Basic copper carbonate. All right, basic copper carbonate. So we got a mixture of copper hydroxide and copper carbonate, basic copper carbonate of green color. That's what corrosion of copper. Do let me know your silver is also getting corroded when hydrogen sulfide gas, the one that's coming out of sewage, is affecting it and giving a set of products. So what will be the product when your silver is getting reacting with your hydrogen sulfide? Okay, do let me know your answer, students. Okay, so I hope this is pretty much clear. There is no denying in that. Yay. And do let me know what are the prevention method we can use for the same. So let's talk about rancidity. That's rancidity. What exactly is rancidity, students? Look at your fresh oil and that's your rancid oil. Your fats and oils are getting oxidized due to oxygen present in the atmosphere and will give you a foul smell and bad taste if you use the same. So you know that when your favorite food, after some time, it happens so many times that when you taste it, oh, that tastes bad, pathetic. The reason is generally this, not like that was made bad, okay? Because the oil used was getting oxidized and convert to this rancid form that's giving foul smell and bad taste. This process is called as rancidity. This is a picture of avocado. See, because it's having so much of fat into it, oil into it, that's getting oxidized. Yes. So how you can prevent your substances and food from rancidity? Rancidity is because of oxidation, right? So if you're preventing this process of oxidation, that will be good. What you can do, you can put some antioxidants in your food. That's what generally those the packets that you got is carrying it. They have some antioxidants, that is allowed one, antioxidants that is preventing your oxidation. Apart from that, flushing nitrogen gas also, sometimes they do this. They took oxygen out and put nitrogen gas, kind of inert, and preventing your oxygen to react with the fat and oil. So that food will last longer. And keeping it in airtight container, keeping your food in refrigerator, because in the cold temperature, your process of rancidity will be slowed down, not like completely away. Yeah. So these are the methods that you can prefer to prevent your rancidity. And I hope all of my hard work will not go into vain and you get the entire lecture. It was a big one, but I tried to set the entire picture in front of you in this chapter. So students, happy that chemical reactions and equations absolutely done and are done. So come and see the way we work in Vedantu platform. There is a link given in description box. Just click on that, select your grade, 10th, select your target CBSE and take your subscription for 1 month, 3 months and 6 months. Choice is yours. It's just the amount of discount you are going to get after applying a coupon code, that's AGEPRO. Anuba Gaur's NAM code is AGEPRO. Apply it. You can save from 20 to 43%. 1 month, just give it a try. 2159, 3 months will be the best one at that moment of time, because almost 3-4 months are left in your exam and you can save 31% on MRP. Do not forget to apply the coupon code. Do not forget to visit the link. Do not forget to like, share and subscribe to the channel and support it equally. This is like a must video. Do not forget it. Okay, students. So I'll take a leave. I hope after the session is done, we can still have some 700-800 likes. That is like important. So I'll see you next time, students. Until then, take care of yourself. Bye bye. Have fun. Keep revising. Happy learning.